Hello, I'm going to explain object-oriented programming, the basic idea of it. A lot of students start out programming doing what's called procedural programming, but we are going to make a pivot now to object-oriented programming, and I'm going to explain exactly what that is. Procedural programming assumes a world full of verbs, of actions. And that the world is made of actions and that a program then should be a bunch of actions. So if you made a bank program, you might have actions like withdraw and deposit and transfer. And all of these actions live together almost like a little machine that just takes input and cranks out output. But object-oriented programming assumes a world of nouns. Customer, money, account, and those nouns can commit actions. They can do things. They have the ability to behave. Each of these nouns, like customer, has data and has actions, has attributes and what are called methods. So we're going to take a second to look a little deeper at what that means. For example, let's say we had a class. A class is a category of thing. The highest level, it's the category of the thing. Here is a class called car. Car is an abstract concept. Car does not exist in and of itself in the world. But cars do. They are what are called objects. Well, in order to have cars, you make them out of this blueprint called a class. The class for a car would have some methods like refuel and get fuel. It would have set speed and get speed and drive and a whole bunch of other methods, a bunch of verbs, things that a car can do. It also would have a whole bunch of attributes, sometimes called fields, sometimes called class variables, like fuel or fuel level and max speed and current speed and are the headlights on as a boolean and that kind of thing. Lots of data that lives inside of a class that can then be applied to each individual object. Each object is a car. I don't actually have ever heard of a polo car before, but let's assume that's a type of car. Let's say this is a Mini Cooper and this is a VW Beetle. Those are different types of cars, but they're all cut out of the same blueprint, the same cookie cutter here, car. So they have slightly different attributes. Maybe their methods work a little bit differently. Maybe one of them has a bigger fuel tank and one of them can go faster. The attributes of these objects are slightly different. But the object is the thing that is concrete in the program, actually, or in the world represented, and the class is the thing that is abstract, meaning it doesn't exist in and of itself, but it is a category of a thing. So let's take a look at another example. Here's dog. You could have a class called dog that has fields or attributes called breed, size, age, and color, and it has methods or behaviors called eat, sleep, sit, and run. And here you instantiate three different dogs. One that's a Neapolitan Mastiff. It's large. It is 5 years old and its color is black. This one is a Maltese with different data. And this one is a Chow Chow with different data as well. The instantiation of these breeds gave different data to the attributes. That's pretty cool. So far we've looked at car and we've looked at dog, but you probably are wondering, like, where is this in my life? Where can I see this? Well, if you play video games. Oh wait, we're not there yet. We're not there yet. The cookie cutter example needs to be given. So here is the idea of a class. It is an abstract concept that only exists in your mind. But you can make a little cookie cutter out of that concept with attributes and methods, meaning with data, fields, information, and actions. And then you can crank out a whole bunch of objects. Those objects could be identical, like these cookies here, or they could be totally different, like these dogs. But like I was about to say, I'm going to give you 3 examples of objects in the real world, or in the real computer world here. The first one is any video game you've ever played, especially a first-person shooter game like Fortnite here. We have players. There is definitely a player class in this game. There's 1, 2, 3, 4, 5 different players. Player is a class. Each of these individual players is an object of that class. They have different skins, they have different behaviors, they have different health levels. Once they're in the game, their attributes are changing constantly. They have different methods for, they might have different methods. They might have the exact same method for shoot, for run, for that kind of thing. The same with the weapons. The weapons are there's a class called weapon, or probably a class called gun, and a class called bullet. The bullets are probably instantiated objects that are different. You probably have more powerful bullets in some guns and other guns don't. And each of these things is a class that is instantiated, meaning made real in this program as an object. Other things that are classes in here are probably every single brick in this wall is an object of class brick. Every single board right here is an object of class board. If there's a vehicle, there's probably a class called vehicle, since there's different types of vehicles in this shot. There's a building. There's probably a class called building with an instantiated object that looks like that, one that is drawn by the artists of the game like that and has certain attributes. So a game like Fortnite here is so full of classes and objects, it's almost second nature to you. The reason for this, of course, is to create a realistic simulation. Our real world is full of categories of things and actual instantiations of those things, actual concrete examples of those things. So we want to create things in the computer that are modeled after the world that we live in, which is a world of nouns, not just a world of verbs. So those nouns, player, gun, bullet, can do things. Run, shoot. I don't know what the bullet does. It's probably has a trajectory and stuff like that. Maybe even explode once it gets there. So let me show you a couple other examples. Twitter. Here is the computer science, hashtag computer science tweets on Twitter. Every one of these, every tweet is an object. It has data, like how many likes, whether or not it's been retweeted, how many comments. It has data like what is the body of the tweet, who is the user that sent it, what is their username, how long ago did they send it. All that data exists in this object, but there is an abstract idea, a class, that is called tweet. And tweet has all of that data inside of it. It also has behaviors like this one is DM this person. This one is reply to this with another tweet. Here's some behaviors. You can do all these things. These are all the methods that would exist within tweet. That's pretty cool. Here's another example. Here's a playlist that I have on Spotify. And, each one of these is a song. There's lots of them. This is a big playlist. Song is most certainly a class within this application called Spotify. So song is an abstract concept. There is no such thing really as song except for an idea inside of our head of what a song is. And the songs have length. The songs have names. They are associated with an artist. They are associated with, there's an album that the song exists on. All of that is the data of the song. The song then also has the ability to be played. The method here of play is one of the behaviors of this song. So each of these is an object of class song. You can also do these other methods. You can do lots of behaviors on a song. You can add it to a playlist. You can stop it. You can skip it. You can do a lot of things. I'll shut this off now. There's a greater class here, though, called playlist. And a playlist has a created by, a how many songs are there, how many hours. It has the list, an array of songs in it. It has the methods like the ability to be shuffled. It has methods like go to playlist radio and make secret and delete. Uh-oh, I don't want to do that. So a playlist is a class of its own. And this is an object of class playlist called FlowTunes that I really like to put on when I'm coding. It's all instrumental songs. This is a shameless plug for my my FlowTunes playlist. Good stuff. Good stuff. So anyway, this has been an example-filled video of classes and objects and how they work. I hope it's been helpful.